Hello everyone. I am Dr.V. Vijaya Bharathi, Assistant Professor of Mathematics, Sri Sharda College for Women, Salem. Now I am going to take the differential calculus. Differential calculus plays very important role in the branch of mathematics. Now I am here going to take about the what is meant by differentiation, introduction of the differentiation and what is meant by differentiation and what is meant by derivatives. Then I'm going to take what are the properties of the derivatives. And fourth one, I'm going to take what are the techniques used for differentiation. Then what is meant by successive differentiation. And finally, I'm going to take what is meant by Leibniz theorem. Next, first introduction about the differential calculus. Differential calculus is a branch of mathematics concerned with the study of the rates of change of functions using the tools of limits and derivatives. That means it's very important branch of mathematics. There are two important branch of the mathematics. One is differential calculus and other one is integral calculus. Now we are going to see here differential calculus. That is nothing but rate of change of functions. What is meant by rate of change? For example, if you are taking in our day-to-day life, current is passing. We are using the current in our day-to-day life. What is meant by current? There is a relationship between the current and the differentiation. For example, if you are taking X as the electric charge, the rate of change of electric charge is called current. See one more example for differential calculus. That means rate of change. If you are taking X as the displacement, then rate of change of displacement is called velocity. And also it is called first order differentiation. Then what is meant by second order differentiation? That means rate of change of displacement. First we see rate of change of displacement. That is called velocity. Then rate of change of displacement is called acceleration. Then again we put rate of change. Rate of change of displacement is called chunk. So rate of changes for the functions using the tools of limits and derivatives called as differential calculus. So what is meant by differentiation? The process of finding a derivative is called differentiation. What is meant by derivative? Derivative is denoted by dy by dx. Here, x is the independent variable, y is the dependent variable. How we say x is the independent variable and y is the dependent variable? For example, if we are taking, suppose y equal to x squared. If you are substituting the value for the x, that means we are substituting x equal to 1, then automatically y depends upon the x. Y values changes to 1. Suppose we are substituting the value x equal to 2, then 2 squared equal to 4. Y value is 4. So y is depending on the value of the x. That is called, so we call it as x is the independent variable and y is the dependent variable. dy by dx. Here, rate of change with respect to x. If x is the displacement, rate of change of displacement is called velocity. This process is called differentiation. Then what is meant by derivative? Derivative of your function is the rate of change of y-axis with x or slope at a point. These are the differentiation. These are the difference between the differentiation and the derivative. Then next slide we are going to take properties of derivatives. What are the properties? There are several properties for the derivatives. First, we see the basic properties. First property is derivative of a constant. d by dx. C into f of x equal to C into df by dx. If you are substituting the C is represented as constant. If you are multiplying the function into a constant is equivalent to the after differentiating this function is equivalent to differentiating with respect to x and then multiplying with constant. Both are equal. So first property of the derivative is constant, derivative of a constant. Then second property, sum and difference rules. What is sum and difference rules? If we are adding two functions and then differentiation is equal to, if we are differentiating first function and the second function, then adding it is equivalent to the sum of the derivatives. Similarly, it is equivalent for difference rules also. Then multiplication rule or product rule. If we are multiplying two functions and then take differentiation is equivalent to differentiating first function and then multiplying second function, adding to that, multiplying first function, then the multiplication of differentiation of second function. It is called differentiation of product rule. Similarly, we can derive it for quotient rule also. These are the basic properties for the derivatives. Next, we are going to see techniques of differentiation. There are various techniques of differentiation. First, we have to see basic differentiation, differentiating implicitly, chain rule differentiation, higher order differentiation, slope. In differentiating implicitly, we are going to see slope, tangent, normal of implicit functions. So these are the techniques we are using. There are various techniques also there. Some basic techniques are given here for your kind reference. So next, basic differentiation. Basic differentiation, all you should know. What is the basic differentiation? If we are differentiating, suppose we are taking y equal to x, then what is meant by dy by dx? Differentiating with respect to y equal to x is a function. Dy by dx is differentiating the function y with respect to the variable x. So y equal to x, then dy by dx equal to 1. Suppose we are taking y equal to x squared. So function is y equal to x squared, differentiating with the variable x. So dy by dx equal to 2 into x. These are the basic differentiation. Then we are seeing about the differentiating implicitly. And this differentiating implicitly, we are going the slope, tangent, normal of implicit functions. Now we are going to the slope, tangent. Next slide, we are going to see slope, tangent, normal, implicit functions. Okay. For example, if you are taking here the function x cube plus y cube minus 9xy equal to 0. See the drawing of the curve axis. In the x-axis, we are pointing 0, 2. In the y-axis, we are pointing 0, 4. Here, we have to find the slope, tangent, normal, implicit functions. Slope, we are drawing this line as slope. Horizontal line as slope. In the curve, we are taking one point as the normal, that is M2, tangent curve, that is linked to the curve M1. Okay, see that normal and tangent curve are perpendicular, so that the value is M1 into M2 equal to -1. This diagram clearly shows that the implicitly functions and the tangent and normal curve are perpendicular. Okay, next we see the second slide. In the above slide, we are seeing the how the tangent and normal curve are drawn. Now we are going to see about how to calculate the tangent and normal to the curve at the point in one point. Okay. So our heading is find, next question is find the tangent and normal to the curve x squared minus xy plus y squared equal to 7 at the point minus 1 comma 2. Okay. So we first we have to we take that the equation x squared minus xy plus y squared equal to 7. Plot the points and draw the curve. First we draw the curve at the x-axis horizontal line, y-axis as vertical line. Then draw the curve for the equation x squared minus xy plus y squared equals to 7. Then we have to put the point because they are given the point as minus 1 comma 2. So in the x-axis, we plot the point as minus 1 and the y-axis we plot the point as 2. That the point is for the point is lies on the function, that curve. That means x squared minus xy plus y squared equals to 7. That curve we point at the point. Okay, next we draw the tangent line and also draw the normal curve. Next, we have to find that tangent line and normal line are perpendicular. We have to check this equation. We have the properties m1 and m2. m1 into m2 equal to minus 1. We have to check that the point. These are the slopes of the points. Okay, first we have to find dy by dx. So first we have to differentiate. Differentiating x squared is 2x minus xy. So differentiating xy in UV method, x y dash plus y. Then we have to differentiate y squared. 2y into dy by dx equals to 0. So taking the dy by dx in one side and the other as the function, remaining portion of the function is to the right hand side. So we get the answer as dy by dx equal to y minus 2x divided by 2y minus 6. Now we are going to find the slope of the tangent at minus 1 comma 2 at the point. Dy by dx at the point minus 1 comma 2 is, we are substituting the point. Dy by dx is already found. We have to put the values of the equation. Minus 1 comma 2. Minus 1 for x and 2 for y. Substituting the values for the x, we get the answer is 4 by 5. So the equation of the tangent at the point minus 1 comma 2 with a slope 4 by 5 is y equals to 4 by 5x plus 14 by 5. That equation comes from the equation formula y minus y1 equals to m into x minus x1. Similarly, we have to find the slope for the normal at the point minus 1 comma 2. Next, we have to find the point. Okay, then again you substituting the point in this slope curve. The equation of the normal minus 1 comma 2 with the slope is minus 5 by 4. And this equation is represented as y equal to minus 5 by 4 x plus 3 by 4. Okay, so here slope is that m1 and m2 is considered as m1 as 4 by 5 and m2 was 5 by 4, minus 5 by 4. So simplifying it, cross multiplying, the value of the m1 and m2 is minus 1. So we get the correct answer. So find the tangent and normal to the curve is always m1 into m2 equals to minus 1. Clearly shows that both are perpendicular. Then we move to the next slide. Techniques of differentiation. Again, we are going to see here basic differentiation. In this differentiating implicitly, we are seeing slope, tangent, normal of implicit functions. Then we are going to see chain rule differentiation. What is meant by chain rule differentiation? Again, linked differentiation. And last, finally, we see the higher order differentiation, and at the higher order differentiation, we see about the successive differentiation. We move to the next slide. Successive differentiation. Okay, what is meant by successive differentiation? Successive means the order of the differentiation gradually increasing. Yes, first I told you, very earlier I told you about the displacement, velocity, acceleration and jump. Yes, here we are taking y equal to f of x. Suppose we are taking y equal to some f of x as displacement. First order differentiation is velocity. Second order differentiation is rate of change of velocity is called acceleration. Again, third order is rate of change of displacement is called jump. So these are the basic examples up to third order. Similarly, we are going to increase up to nth order. So the nth derivatives of some special functions we are going to see. So successive means next functions. Next gradually increasing functions. Successive differentiation. Okay, so the nth derivatives of some special functions. First, we see about the differential coefficient of x power m. How to differentiate? Okay, for example, if you are taking x power 1, we are differentiating means 1 x power 0. So 1 into 1 equals to 1. Suppose we are taking second order, x power 2. 2 into x power 1. So 2x. Suppose we are taking x power 3. Means 3x power 2. Okay. So similarly, we extend up to mth power. So yn equal to differentiating with the nth order for the coefficient of x power m is m into m minus 1, m minus 2, m minus 3 up to m minus n plus 1 into x power m minus n. Okay, this is first function. Next, we are going to see about the differential coefficient of ax plus b whole power m. Similarly, we are taking as a is the coefficient of x. So we take it as we up to nth order, so a power m. And similarly the function like the above step. So m into m minus 1, etc. m minus n plus 1 into, instead of x here, ax plus b whole power x power m minus n. Third one, we are going to see differential coefficient of ax plus b. So the formula is y power n equal to minus 1 whole power n minus n, a power n minus 1 factorial divided by ax plus b whole power n. These are the basic properties or basic differential coefficient which we have used in the successive differentiation. Next, fourth one. Similarly, for trigonometrical functions, some of the formulas are situated here. y1 equal to a cos ax plus b into a sin pi by 2 plus ax plus b. Similarly, for generalizing that term, next cos ax plus b. Eighth one is differential coefficient for 1 by x plus a. That is yn equal to minus 1 whole power n factorial x plus a whole power n plus 2. Ninth one is differential coefficient for logarithmic functions. So yn equal to minus 1 whole power n minus 1 into n minus 1 the whole factorial x plus a the whole power n. And the 10th step is, the last one is differential coefficient for the exponential function. Suppose we are differentiating the exponential function again repeated. So the instead of that y power n, yn equal to a power n e power ax. These are the some basic differential coefficients which we are used for the problems. Next, find yn for the function y equal to 1 by ax solution. So using the above formula, minus 1 whole power n plus 1 a minus x whole power n minus 1. Okay, next, see the second problem. Find yn for the function y equal to 1 by x squared plus a squared. Here, denominator is x squared plus a squared. So we have to split into partial fractions. Before that, we are splitting, if it is any possible to split it in two functions. So x plus ia into x minus ia. So split into partial fractions, we get 1 by 2 ia, 1 by x minus ia minus x plus ia. So using the above formulas, we get the answer. So these are the problems. Next slide. We are going to see techniques of differentiation. So till now we are seeing basic differentiation, differentiating implicitly we see slope, tangent, normal of implicit functions. Next we see chain rule of differentiation, and finally we are going to see higher order differentiation. In the higher order differentiation, we already saw successive differentiations, and finally we saw Leibniz theorem. This is Leibniz. Next slide. Leibniz theorem is very most important role in the successive differentiation and higher order differentiation, because Leibniz founded this. Regarding the honor of the Leibniz, this theorem is called as Leibniz theorem. Leibniz theorem is nothing but nth derivatives of product of two functions. In successive differentiation, we see the nth order derivative. Here, nth derivative of product of two functions we are going to see. Okay, statement. If u and v are two functions of x, then the nth derivative of the product is defined by uv whole power n means u power nth derivative of the u into v plus combination of 1 n minus 1th derivative of u into v1 plus nc2 u power n minus 2 p2 etc. u into vn. This is the product of the Leibniz theorem. So students, till now we are seeing what is meant by differentiation. Till now we are seeing what is meant by differentiation, what is the use of the differential calculus, what is the difference between the differentiation and differential calculus. Then we are seeing basic differentiation, chain rule, higher order derivatives. In higher order derivatives, we see successive differentiation, and finally seen the Leibniz rule. Thank you so much, students.